Hey guys, welcome back to my channel. I'm actually here to try to do an updated video on how to name and write ionic formulas. Now we're going to start back with what I did in the very first original video. I figured since about 10 years has passed, it's about time to update some of these videos just so the picture quality and the sound quality be much better. So let's go ahead and start. Well, first of all, you're probably asking yourself, what in the world is an ionic formula? Well, basically, you need an ionic compound. Now, the only way for sure to know if you have an ionic compound is to look at their electronegativities. Now, the easiest way to identify that you have an ionic compound is basically to see if you have a metal and a nonmetal together. Now, that's not always true, but for the most part, if you have a metal and a nonmetal together, you're going to have an ionic formula. So you can use the naming rules of ionic compounds. So let's go ahead and start with a classic example. Okay, let's say you're looking at a periodic table. Now let me pull one up here. Okay, now a periodic table is laid out to where you have metals and nonmetals. Now I'll go ahead and tell you, predominantly almost everything on the periodic table is metals. So almost all of column 1 are all metals, okay, except for hydrogen. Hydrogen is definitely not a metal, but from lithium down to francium, those are metals. All of column 2, so basically everything on the left-hand side of the periodic table. So from column 12 all the way back over to here are metals except for hydrogen. Now even this block down here, a lot of people like to call this the lengthened actinide series. Some people just call it the F block, but this is metal. All these are metals, transition metals, the alkaline earth metals, and the alkali metals. Now we do have hydrogen and helium, and we have the noble gases and halogens, and this is basically where our nonmetals are. Our nonmetals are usually to the upper right hand corner of the periodic table. Yes, there's fewer of them, and this diagonal here are the metalloids. Okay. Anyway, so what we need to do is identify if we have a metal and a nonmetal together in order to be able to name these compounds. So let's go back. So here are the rules for writing ionic formulas. You have a cation, that's positive. You have an anion, that is negative. It's always second. But the objective is you want these to become electrically neutral. That's why they form in the first place these compounds, so they can become neutral. So let's go ahead and get started. So we will pick a metal, okay? The metal that we're going to start with is sodium. It's over here, okay? So we're going to write down sodium. I'm just going to write down these names so we can see that that's what we're using, okay? We have sodium, and I'm going to combine sodium with a nonmetal. Well, let me pick a nonmetal out. So I'm going to go over to the top right-hand corner here. Now, normally you will never pair one of these with a noble gas. Now here's why. The reason why you will normally not pair one of these with a noble gas is because noble gases are stable. They don't want to bond with anything. Okay. Now you can do some weird things, and you might get krypton and xenon to do that, but for the most part, we will never combine with a noble gas. Okay, when we're looking for nonmetals. So over here, we're going to pick chlorine. We want to somehow combine sodium and chlorine together. So here we go. Chlorine. We want to put these two elements together. Now, since we're dealing with ionic compounds, if we're going to try to write this formula, then what we would do is we would look for their ions. Now, let's go back to the table. Now, these ions have charges, okay? Cations with a T, C-A-T-I-O-N. Notice it's got a T in it. So does the word metal, M-E-T-A-L. They both have T's, so that's a positive. So metals are always positive ions. Column number 1, yes, even this hydrogen, is a positive 1 ion. Now, column number 2, same thing for it. It's going to be a positive 2, okay? Now, we're going to skip the transition metals because there's a lot of them in there that's pretty weird. The only ones I can tell you right off the top of my head that are not weird, scandium is a positive 3 charge. Zinc is a positive 2 charge. Cadmium is a positive 2 charge. And silver is a positive 1 charge. Other than that, I can't tell you because a lot of these jump around in their charges and stuff. For the most part, this column 13, most things in it will be a positive 3. Now, I'm going to skip column 14, I'm going to go ahead and go all the way to column 18. Column 18 does not have a charge. It has a 0 charge. Column 17, most things in it are -1. Most things in column 16 is a -2. Most things in column 15, -3. And I've always had a habit of writing plus or -4 for this column, so I'm going to continue that trend. And what I've always said is if it's a metal, you know it's a metal, give it a +4. If it's a non-metal, give it a -4. So, for example, carbon would be a -4 charge if you needed an ion. Silicone, you're probably going to have to like look and make sure, but for the most part, we'll say that it's going to be a -4 as well, even though it's a metalloid. So, anyway, let's go ahead and go back to our naming now. Okay, so we need the sodium ion. Well, sodium, if you look, is right here. It's in column number 1. Its charge is going to be a +1. So the way that you would write the sodium ion would be Na with a +1 charge. That's it. That's how you write the sodium ion. Now, if you need the chlorine ion, it would be pronounced a chloride ion. You would write this. Notice that chlorine is in column 17. I've written a -1 charge above it. That's going to be the charge of that ion. So, Cl would be a -1 charge. Now, if you're trying to write this formula, this charge is a +1. This charge is a -1. Now, the plus and the minus do nothing more for us than to make sure that we write the one that's positive first and the one that's negative second. After that, the plus and the minus are not needed to figure the formula out. Since these numbers match, we're not going to write them. Okay, so our formula would be just NaCl. Now here's the reason why we're not going to write the ones. If we wrote it, it would be written this way, Na1Cl1. That kind of looks silly. Well, just to make the formula appear more clean, I guess more condensed, we don't write ones. That's just a rule that was stated long ago for naming these compounds and writing the formulas. When we're doing subscripts, we just don't write ones on subscripts. Just remember, you're not going to have a subscript of a 0, so never write a 0 for a subscript, okay? At least in these binary ionic compounds that we're doing. And the reason I'm calling them binary is because we only have 2 elements. We have sodium, we have chlorine. So that's what it means by bi. So if you ever hear binary, that's what that means. Just 2 of them, okay? Now, if we wanted to name this, what you would do is you would just name the metal. The metal, once again, would just be called sodium. Okay, now to name this next part, since it's a nonmetal coming from the front of the periodic table, we're going to name this one chloride, R-I-D-E. Notice that all that we're going to do is we're going to drop this I-N-E ending and add I-D-E. I mean, that's it. That's all there is to naming this. Now, if you were asked to name the individual ions, if you had Na+1 and you were supposed to name this ion, this is how you would name this ion. This individual ion would be named sodium ion. Now, if you were asked to name the individual ion Cl-1, you would have to write this as chloride ion. Okay, so that's a chloride ion, and this is a sodium ion. Now, if you're still kind of confused of why we're naming it chloride, let me show you something that one of my college professors showed me. All right, we're dealing with the element chlorine, okay, and we're trying to find an appropriate name for it. Well, if you look, there's 1, 2, 3, 4, 5, 6, 7, 8 letters in chlorine, okay? So the middle would be somewhere right in here. So basically you take the word, you cut it in half. So you got C-H-L-O and you got C-H-L-O-R, okay? And you just work your way backwards and forwards, dropping and adding letters of the root, or base word, you could say, C-L-O-R-I. And on all of these, you just add this ending of I-D-E, okay? And eventually, you will find one that actually sounds really nice. So like this, I'm not even sure if I can pronounce chilide. This doesn't sound good. Chloride sounds pretty good, but still sounds kind of weird because of the two vowels there. Chloride sounds really good, and this one is chloride. Sounds kind of silly. So notice that if you have trouble figuring out how to spell the nonmetal with the IDE, you can always do this method, and you can have success doing this. This just takes a long time. But the more that you do these, the better that you will get at figuring out how to name them and to write their formulas. So luckily for us, we were able to go over naming the element and writing the formula and naming the individual ions. So we managed to get a lot covered in this one video over this one specific element. Alright guys, I hope this updated version of this was helpful and informative. So you guys and gals have a great day.